Hi, welcome to Kaito Tutorials. Today is day 4 of the Software to Machine Learning 365 challenge. So in today's video, we're going to do a little math because there's no machine learning without math. In particular, we'll look at the calculus side of things, and today we'll look at derivatives. You may ask, what is a derivative? Well, this is the instantaneous rate of change of a function with respect to one of its variables. How is it important to machine learning? Well, machine learning uses derivatives in optimization problems. More specifically, optimization algorithms like gradient descent use derivatives to decide whether to increase or decrease the weights in order to maximize or minimize some objective. For example, to tune the accuracy of the model or error functions. Join me in this journey as we go towards machine learning. Please like and subscribe, and let's get started in this video. Okay, so what we have here, we have a few problems that we're going to work through. We're going to work it by hand. Then what we're going to do, we're going to look at how do we represent some of these functions, methods, derivatives via code. We'll be using something called sly, sly sys pi. Syspy will be giving us the ability to actually use derivatives and even the future integrals and other things, other mathematical functions. It's built off NumPy. Okay, let's get started. So let's look at 1a. So in 1a, let's choose a different color. Let's work it out the old-fashioned way. So to find the derivative of x squared, what we'll do, we'll say derivative. So we'll take 1, and so we will be left with 1, and we'll carry 2. So therefore, the answer is 2x. That is the answer. Okay, let's go to the next one. Okay, what is the derivative of x? Well, the derivative of x is just 1, because this is really what is there. There's really a 1 there. When you don't see anything, it means that there's a 1 there. So if you take 1 from that, you have 0. And a 1 was carried down. So that's how we end up with 1. Let's look at another example. What is the derivative to find for 1 over x? Well, there's a substitution that can be used for this one. So the derivative is really ln, so natural log of x. Okay, so let's go down to 1D. 1D, it looks similar to 1 over x, but it's not the same. So it may look a little complicated, so here's what we'll do. We'll try to break it apart by rewriting it so that it's more familiar, and then we'll work on it and put it back together. So what we'll do, we'll say y is equal to, so actually 1 over x squared is another way to write it is x to the negative 2. Right? So let's say minus 1 from it, and that is going to give us minus 3. We carry the negative 2 here, so we have negative 2 times x. So that will give us negative 2x to the negative 3. Okay, so let's rewrite this portion, the x to the negative 3. And what could we rewrite it as? In rewriting it, we'll end up having 1. This is the same as 1 over x to the 3. And then we'll have negative 2 times negative 2, which can be simplified. It can be simplified to say 2 over x to the cube, and we need to leave the negative sign at the front. Okay, so let's go to the next example. Okay, so we have ln x. What is ln x? Well, the derivative of ln x, I wonder what that could be. Let's look back. So in the previous example, we had found the derivative of 1 over x, and we ended up with ln x. So what do you think that would be? So when we go back to n, we'll say the derivative of that is therefore 1 over x. And that's our answer. Okay, that's the last one that we're going to do for today. In future episodes, we're going to do much more complex examples. Maybe we'll do like chain rules, product rules, and go through the different ones if you'd like me to go deeper into derivatives. But the purpose of this video is just to show how it is that you can do it by hand and how you can write it in code. Okay, so in this example, I like to break it down a little bit into phases. So to find the derivative, let's try and find the derivative of e to the 2x first. Okay, e to 2x is 2, 3 to the e to the 2x. Okay, let's work on this section here. We know that we'll carry 3, so it's going to be 3 minus 1 equal 2. So this is going to be 3 to the x square. Then we have a minus here, and we'll say 1 minus, one second, say 2 minus 1 equal 1, and we carry the 2 down. So 2, so we'll end up having negative 14 x, negative 14 x to the 1, or you can leave it as is without putting a 1, because it's assumed that the 1 is there. Sympy as sim. Okay, we need to be careful with this autocomplete. I'm not trying to get system. Okay, then from sim, from sympy, would like to import derivative, and we can also import things like tan, or even things like sine, or we can import everything by using the asterisk sign, this sign, if we wanted to. Okay, so let's create another code block, and what we're going to do here, we're going to create a function, and we're going to say I'm going to show you how to do a derivative. So I'm going to say sim dot diff, and then in order for you to write x to the 5th, what you'll need to do is x times to indicate that it's a power. If you want to just do the normal, say x or 5x, then it'll be 5 times x. So x times 5. Okay, then we're going to say, let's create a variable called d, and then we're going to pass the function inside of the derivative, and let's pass a function, and let's see what's inside this function. Let's see. So x was not defined. So let's define x. X is equal to sim dot symbol, and let's say the symbol is x. Let's rerun this. So as you see, the derivative d over dx, 5 to the x to the fourth. That is what we have here. That is a derivative that we have in this case, because what it is before everything was done, it was x to the fifth. And so if we want to see, so basically what happens is that it was x to the fifth, and so if you took the derivative, so if 5 minus 1 gives you 4, and you had taken the 5 down, so that's why you have x to the fourth right here. Okay, what if I would like to do a second derivative on this? Then let's do a second derivative. We can use d dot do it. So dot do it, and it's going to run it again, and this time we have 20x to the third. So we have taken, so in this instance, let me zoom in a little bit more. In this instance, we have taken we have carried the 4 down, so 5 times 4 is 20, and then 4 minus 1 is 3. Okay, so we see how we can write it and how we can run it multiple times. Let's look at a different example. So another thing that we can do, let's just call this one y func. So we just call it y func just to differentiate it. Alright, let's do something else. Let's use, what about using x to the fifth? So that what we're going to do, we're going to say symbol.diff, then we're going to say x to the sixth, and we're going to find the derivative of this one, and we're going to end up with about 6x to the fifth. Okay, so each time you notice I'm writing diff every time, sim.diff, why not just create a function and reuse it? So that's what we're going to do now. And then once you create this function, which is pretty simple to do, we're going to do the same questions that we did by hand earlier. So what I'm going to do, I'm going to create def, and we're going to call it find derivative. Then we're going to the parameter we'll use is called expression. You can call it anything that you like, and we're going to return sim dot diff, and instead of passing every time a hard-coded value, we're going to pass the expression that we have passed. Okay, so let's run this. Good. So let's experiment and see if this works. So let's copy the name. So this is just a test of the function. So what we're going to do is call find derivative, and we're going to pass expression. Let's copy this for future use. And what we're going to say is x squared. Let's see what it is. We should get 2x. Voila, 2x. Okay, now that we have done that, what we're going to do now, we're going to now recreate all of the questions that we had done earlier. So what I'm going to do first, I'm going to import all the remaining functions that we may have not used before. So from sympy import everything. So import all. So now we're going to create another section. So in this section, we're going to add all the questions. So the first one, so I'm going to go through as quickly as possible. A, which will be x squared. B, so those were what we had done earlier. B will be just x. C is going to be 1 over x. D is going to be, let's see, 1 over bracket x squared. Then n is going to be, going to use, we need log n, natural log. So what we'll do is use sim dot ln x. That's how we're going to get this particular one. Instead of calling, if we didn't, we would have to say import ln, import tan, import etc. So next we're going to say I. For I, we need tan x. For f, we need the we need e of x. So exponential x. And you can see that it's giving you examples of what exponential function is. Okay, we'll need also for u an exponential function, but inside there we need 2x inside the exponential function. Then finally, let's call this one ex1. So this was one that had a combination of multiple multiple components that we had to work out. So we need an exponential 2x plus x cube plus 7x squared. Okay, now that we have these functions, what we're going to do now, we're going to start calling them one by one. So the first one that we needed was 1a. So 1a. So we're just going to put in the expression a. And we have 2x, which is correct. The next one is going to be b. So that would be 1b. B should give us 1 because as we had worked it out, it had after what x really is, after 1 minus 1, it's 0, so that gets rid of the x, and 1 was carried over, or carried down. Okay, next we have 1c. So 1c should give us about negative 1 over x squared. Correct. Then we'll have 1d. And 1d, let's see what d was. What was the question? For d, it was 1 over x squared. The answer is negative 2 over x cubed. Correct. The next one is 1n, because we had skipped a few. So 1n. So when I put in expression n, the answer is 1 over x. And then the final one that we'll have to look at is, it was question 2.1, and we'll call it ex1. So ex1. So ex1 here. So let's see what comes out to. Okay, 3x squared plus 14x, correct, that's what we had, 2e to the 2x, which is correct, which was exactly what we had. The order may be different, but same result. Okay, so this was just a taste into derivatives. In the next episode, we're going to look at integrals. We're going to work a few integrals and see what happens. Then what we'll do after that, we'll experiment with a little gradient descent linear regression to predict some prices. Then after that, how the series is going to go is that one day we're going to do coding, mainly coding. Then the other day we'll do some math if we can do a little coding to represent the same concept using Python code, then we'll do that, and they will alternate between the two. So one day code, one day math, etc. As we do questions related to calculus, linear algebra, and statistics, which is the bread and butter of not mathematics alone, but bread and butter of machine learning. Please like and subscribe, and please join me in the next episode. Bye.